Hi again, Mr. C here. Hope all is going well, Algebra Bros. In this video, what I'm going to do is discuss the change of base formula, give you two common versions of it, and then knock out a couple of examples utilizing it. There's going to be a follow-up video showing you how to type in the expressions that we'll write out in the examples at the bottom of the screen. So stay tuned for that. But first, let's go ahead and discuss, why a change of base formula is necessary. We'll definitely be using this quite frequently um, for the remaining sections of our course. So basically, the change of base formula allows you to change the base of any logarithm function that you're working with. So if you're working with a log base 2 and would prefer to work with a log base 10, you are allowed to do so. If you're working with a log base e and would prefer to work with a log base 5, for instance, then you're allowed to do so via the change of base formula. However, there is one small catch. Whenever you change the base of a log, you're only allowed to do so provided you follow the formula, the format of it. All right, so I'm down here right now where it says log base a of b. If you wanted to say change the base to a generic value of c instead of a, then you're allowed to, provided you follow this format. All right, it would need to be written out as log base c, and in the argument of this log will go the original argument b. And what you'd have to do as well is divide this by another copy of log base c, and in the argument of this log will go the original base a. All right, so as long as you follow this format, you can change the base of your log to anything you wish. All right, so I'm going to draw a couple connectors here. All right, so there are two logs, one on top of the other. C is your base of choice, and in the top log's argument goes the original argument. Okay, so original argument. And in the bottom log's argument goes the original base. The change of base formula is really handy, especially if we need to type in a logarithm into our graphing calculator. Most graphing calculators don't have the capability to type something out such as the log base 3 of 17 or the log base 1.5 of 8. Um, so what you're forced to do if you need to type something like that into the calculator is apply the change of base formula. And the most common versions of the change of base formula involve buttons that we do have on the graphing calculator, and those would be the buttons for the common log and the natural log. All right, so with that said, here is one of the common versions of the change of base formula. It uses the log base 10. So let's start here, log base a of b. If we wanted to write that with the log base 10, we can, provided we do the log base 10 of the original argument b and divide it by log base 10 of the original base a. So that's the common log version. Natural log version, which would be the other common version, follows a similar suit, only this time it's going to use the ln notation. All right, so if you wanted to use the natural log version of this, here's how it would look. The natural log of the original argument b, all on top of the natural log of the original base a. Now, surprisingly, it doesn't matter which of these two versions you use. You will wind up with the same value once you punch it into the graphing calculator. So with that said, let's go ahead and work on these two examples. We have the log base 3 of 17. If you wanted to type this into your graphing calculator to get a decimal approximation to it, you'd have to use one of these two versions. And I'm going to go with the common log version. So one way to rewrite log base 3 of 17 is to write it as log, it's going to change color here. Okay, log base 10 of the original argument 17 on top of log base 10 of the original base 3. All right, and I'll show you how to type that in to the graphing calculator in my follow-up video. For the second example, I'm going to use the natural log version, which would force us to rewrite it this way: the natural log of the original argument 8, all on top of the natural log of 1.5. All right, and I will show you how to type that in my follow-up video as well, so that we can get a decimal approximation. But that's really all there is to it, to the change of base formula. Please let me know if you have any questions about stuff that I went over in this video. Otherwise, I'll see you in the next one. Thanks for watching.